The theory of resonance is another abstract concept, and it's very helpful in organic chemistry because it helps us understand the stability of the compound, the bonding, that compound, and of course, later on for reactions and mechanisms. Theory of resonance occurs in when you have the following example. When you have an example where you see this double bond in this compound is one time between the oxygen and the carbon and another time between the carbon and the nitrogen. And then you might ask, which structure should I draw? And the answer, and I'll tell you from now, is both. Because both put together, hybridized together, mixed together, will give you the real structure. So then you say, okay, well, what would something in between look like? Well, in chemistry, we show that as a dotted line. So if you notice here, this bond or this double bond, and there's negative charge on oxygen or on nitrogen, you can say, okay, this solid line, so I'm going to use blue for that, I'm going to leave the lone pairs for now. You can split this double bond, and we show that with dotted lines. And now you can split this charge from a full charge to like a half and a half on there. That's the only way to actually represent both at the same time. Sometimes we show this as a negative delta, partial negative, but we'll get to that later. So the idea is that this arises when you try to measure whether there's a double bond here and a single bond there, and you find that you actually have 1.5, something in between. Yes, it's a complicated theory, but it's very doable, and I'll guide you as much as I can. So let's go back to an example down here. We did this example if you go back to Lewis structures. Now, when I do this example in general chemistry, students always ask me this question, or they ask me two questions, and these are great questions. So if you recall carbonate here, you can pause to draw it and then catch up to me. Students ask this question. They say, okay, well, when I draw this, can I put the double bond somewhere else? Like, can it be there between the oxygen on the left and the carbon? And my answer would be yes. Can I put it between the oxygen on the bottom of the carbon? And my answer would be yes. And then the follow-up question would be, well, which one would be more correct? And my answer would be all of them. You need all of them to represent that same structure. And notice the arrows that I'm using. It's called a double-headed arrow. Those are resonance arrows. So yes, I can actually shift okay, I can shift this double bond to the left, and then of course it can go now in a third structure where it's on the bottom. So when I say all of them represent the same structure, all of them together, that would be true because, again, you could not separate one from the other. In fact, the whole idea of resonance is actually, these are not real structures, but they help us on our level, the human level, to understand what's happening. But you should not think of this as flickering back and forth. All of these are happening at the same time. All of them are happening at the same time. Now, let me show you what we call the hybrid, the average between all of these. So first of all, we need the negative charge, a formal charge, to be shown. Here's a negative, and there's a negative, and there's a negative. Now I'm going to add more space here, and then I'll get to the analogy in a little bit. So this will be a little bit of a longer video because, again, the theory is complex. The average of all of these would be, and I said to you, use dotted lines, is to remove the double bond. And since you have 3 possible resonance structures, that's what we call resonance forms or contributors, draw the arrow, you draw the oxygens. You can omit the lone pairs, and then you use a dotted line Not sure how clear it is, but let me make it clearer here. Okay, so that would be actually the real structure. Now, how would you split the negative charge? Well, you would split it into 3. So this would have a negative 1/3, this would have a negative 1/3, and this would have a negative 1/3. So a third of a negative charge, you can think of it this way. So that would be the hybrid or the average of all of these together. So think of resonance this way, and this would be actually the best representation, but we will learn how to do this because it helps us with reactions. And analogies, think of this way. You have an analogy where you have 2 of your family members, your mother, husband, wife, whoever, father, partner, whoever it is, and you have 2 of them, and they meet a person on 2 separate occasions, but apparently they forgot the person's name. And when they come back to you on also separate days, they say, oh, the person was asking about you. And you say, okay, well, I don't know who is that person. So the next thing they do is they give you physical aspects, descriptions, or characteristics of that person. So you say, okay, well, let's say, not sure, your first family member, right? The first family member describes that person as, say I'm talking about myself, okay? I'll say I was asking about you, okay, that he has, dark hair, okay? He has a bigger nose, that's me, okay? And then he has some kind of a facial hair or something like that. Now, the other family member describes me as saying, well, yeah, he does have, hair, but it's not that much, just a few. Okay. He has also a big nose. But I noticed that also, he has also a big ears. So the combination is, you try to imagine, the combination is, okay, how am I going to combine this? I don't know why my head is square, by the way, but it's a little bit in between. Still retain the nose, still retain the facial hair, and the ears, because the other person didn't give you. So notice that this one is a combination of both. That's the idea. That's what I like to use. Okay. Talking about myself, it's okay. So I'm glad I didn't use someone else. But that's the idea of resonance. In the next video, I will explain to you how to draw resonance structures. But do not give up on this, because I know it can be a difficult topic, but you can get it with more practice and more time understanding the concept.